MCP has a clear architecture and every component has a specific role. At the center of everything is the MCP host. This is the AI application system where the model lives, where the user submits requests, and where the responses are returned. In a production banking system, this might be a conversational interface, a mobile app, or an internal operations tool. In a nutshell, the user interacts here. Inside the host, there is a component called MCP client. Think of it as a translator. The model decides what it wants to do. It determines the intent. It identifies which tool should be called. It prepares the parameters. But the model does not know how to communicate directly with external systems. The MCP client takes the model's intent and converts it into the MCP protocol format. It handles the communication. It manages the session. So you can say it is the bridge within the bridge. On the other side is the MCP server. The MCP server exposes a set of capabilities, a catalog of things the AI is allowed to do. Each capability is a tool. Each tool is a governed, controlled interface to the downstream system, could be our banking APIs. Connecting them all is the transport layer. The MCP client sends a request to the MCP endpoint on the MCP server using a protocol called JSON RPC. The client tells the server which tool to call and what parameters to pass. The server executes the tool and returns the result. The MCP endpoint is not a business API. It is specifically the doorway through which the MCP client inside the AI host communicates with the MCP server. That controlled interface is what makes MCP safe for banking. The model does not have direct access to the banking systems. It has access to a set of approved tools and nothing beyond those tools. Now that we have the components, let us watch them work. There are two flows. The first happens once at startup, we're going to watch it now, and the second happens every time a user makes a request. So let's start with the first flow. When the system starts, the MCP server wakes up. It scans itself, finds all the tools it has registered, and builds an internal menu, a catalog of everything it can do. It is now ready, but nobody knows about it yet. Then the MCP client starts on the other side. It knows the server's address. It reaches out and introduces itself. The server responds. This is the handshake. After this moment, the two sides know each other. Immediately after the handshake, the client asks one question: what tools do you have? The server responds with its full catalog. Every tool name, every description, every parameters the tool expects. The client registers all of it. The model can now see the complete menu of approved actions. That is startup. It happens once. Before any user sends a message, the system already knows exactly what it can do. Now, a user arrives and he says, what is my account balance? The model reads the question, looks at its tool menu, and identifies the right tool. Let's say, get account balance. Now, it has made a decision, but it has not done anything yet. The MCP client takes that decision and wraps it into a structured request. That request travels through a single controlled channel, not to the account API directly, not to the database, only to the MCP endpoint. The MCP server receives it. Before anything executes, the server validates, like is this a known tool? Is the caller authorized? Are the inputs valid? Only after all of it passes does the server call the actual banking service. and the results come back. The server wraps it. It travels back through the MCP endpoint to the client, to the model, and then the model wraps it into a natural language answer like your balance is so and so, and the user got their answer. The model never touched a banking API. It worked entirely through the approved tool boundary, and every step is auditable. So, two flows, one diagram, that is the complete MCP architecture and lifecycle. In the next video, we open the code and we see exactly how this server is configured in Spring Boot. So, see you in the next video.